Today we are going to talk about equations with fractions. So we did a bunch of stuff with fractions yesterday to prepare us for today, right? Because if we just hopped right into equations with fractions and we hadn't reviewed fractions in general, you'd be like, whoa, what's happening, right? So this was meant to make it a little bit easier. So a couple things to remember when we're solving equations. There's two basic steps when we solve equations. The first thing is we want to do opposite operations. Remember, like the opposite of addition is subtraction. The opposite of multiplication is division. You want to do your opposite operations, and you want to get the variable by itself. You can really tell the difference in the stylus quality from line 1 to line 2. I switched my styluses. All right, we remember that? Cool. So solving equations with fractions. Addition and subtraction. Remember the opposite of addition is subtraction. Therefore, the opposite of subtraction is addition. Good. So these equations here, they're like our one-step equations we looked at the first day, except we got some fractions in them, okay? Well, we're going to treat them the exact same way. So if you take a look at number 1, we want to get x by itself, right? So that means what needs to move over? What opposite operation do we need to do to get x all by itself? We need to do addition, right? We're subtracting 1/3. So the opposite of subtracting 1/3 would be adding 1/3. So we want to add 1/3 to the left and to the right. Good. Now, our 1/3s on the left cancel, and we'll just have x equals. And now we just add our fractions. So remember, when you add fractions, do we need to change the denominator? Does the bottom change? No, you only add the top, right? So look at the top. What's 2 plus 1? 3. So we'll have 3/3. Is that a good final answer, though? No, why not? Yeah, exactly. You can change it to a whole number. So 3 divided by 3 is just 1. So we're going to simplify this to just 1. Good. All right, let's look at, we're going to skip 2 for now because I'm going to have you guys go back and try out 2, okay? We're going to go down to number 3. Number 3, we have x plus 3/4 equals 7/8. So what opposite operation do we need to use here? Subtraction, good. We want to subtract our 3/4 from both sides. On the left, they cancel, and then we're left with 7/8 minus 3/4. Can that be subtracted the way it's written right now, though? The bottom needs to be the same, exactly. One of them has an 8 on the bottom, the other has a 4 on the bottom. What could we change that to be? Yeah, so yeah, good. So Annalise and who was that? That was it. Dallas, okay. I can't see you guys. There we go. Okay, so yeah, we can definitely change the 8 and the 4, right? Just make them both 8. So that would mean multiply the second fraction by 2. Do you have to make the denominator 8? What else could you make it if you really wanted to? anything that multiplies to be it. So you could make it 32 if you want it to be, okay? But I always recommend dealing with as small of numbers as possible. So yeah, let's make them 8. So do I need to do anything to the first fraction then? No, we're just going to leave it as, and I'm actually going to move this so I have a little bit more room. I'm going to write on the other side here. And I'm going to have, so x equals 7/8 minus, and then I need to change my other fraction to have an 8 on the bottom. And Dallas said that means we need to multiply our second fraction by 2. So if we multiply the bottom by 2, we also need to multiply the top by 2. Good. Make it a 6. Good. And then just subtract the top numbers. 7 minus 6 is 1. So you'll have 1/8, and that cannot be reduced. So for number 2, we have x plus 7/4 equals 5/4. What opposite operation do we need to do here? Correct, we need to subtract. We're going to subtract 7/4 from both sides. Good. Do we have a common denominator? Yes. So we're good to go. We just need to subtract the top. Class, what's 5 minus 7? -2/4. Which is good, but is it a perfect final answer? Why not, Owen? Very good. This can be reduced, right? 2 goes into both of them. So we're going to reduce this. If you divide them both by 2, -1 divided, or no, I'm sorry, 2 divided by 2 is 1. So we'll have a -1, and then 4 divided by 2 is 2. Good. So this should reduce to -1/2. Excellent. We good with that one? Okay. And let me know if you get hung up on anything, because there is one on the quiz that you have to either add or subtract a fraction. Okay. And then number 4, we have x minus 1/3 equals 2/5. What is our opposite operation here? Adding. We're going to add 1/3 to both sides. Do we currently have a common denominator? No. What would be a good common denominator for 5 and 3? Annalise says 15. I think that's a good idea. So I'm going to rewrite my problem over here with 15s on the bottom. And now we need to figure out how to change the top. So somebody at home, 2/5. I needed to change it to have a 15 on the bottom. What should I multiply that fraction by? 3. Very good. Yeah, multiply the bottom and the top by 3. So the top's going to become 6. Good. And then for the next one, we have 1/3. What should we multiply that by? If we want to make it, we have a 1/3. We want to make it a 15 on the bottom. 5, right? Multiply by 5. And 1 times 5 is 5. Add those up, and you should get 11/15. Okay. Any questions on those? Do we get the idea? Okay. All right. And I forgot to put addition subtraction ones on your homework, so make sure when you're preparing for the quiz that you look at this. We'll do a couple extra practice problems in the morning tomorrow before we start the quiz too, just to like refresh our memories and wake up our brains a little. So here we have solving equations with fractions, multiplication, and division. The opposite of multiplication is division. Therefore, the opposite of division is multiplication. Good. So remember, this is our multiplying and dividing by fraction rules. So when you divide by a fraction, you must actually multiply by the reciprocal. Remember when we did our keep, change, flip yesterday? Keep the first, change the multiplication, or change the division to multiplication, flip the second fraction. That's technically called multiplying by the reciprocal. Okay. Reciprocal means you flip the fraction. So if I flipped the fraction 5 over 3, what would that become, Annalise? 3 over 5. Did you want to answer, or did you have a question? Because you raised your hand. I didn't know if you also had a question. Oh, okay. No. That's good. No, yeah. I just didn't know if you also had a question in addition to that. All right. So let's look at number 1. Now, number 1 and 2, we've actually already done ones like this, right? We're technically dividing by 3 here. Now, the reason I put these on here is this technically is the same thing as saying like 1/3 x, okay? I just don't want you to get confused when you see one of these because now when we're doing the fraction stuff, it's easy to mix it all up. In number 1, aren't we just dividing by 3? It looks like a fraction, right? But we're technically just dividing by 3. So what's the opposite of dividing by 3? Multiplying by 3. So multiply both sides by 3. And what is -4 times 3? -12. Good. All right. So number 2, we got m over 5 equals 6. We're dividing by 5. What's the opposite of, yeah, we're going to multiply. The opposite of dividing is multiplying, so multiply by 5. And what's 6 times 5? 30. All right, so that's just a little review of things we've already done. What's a little different about 3 and 4? Isn't there like an actual fraction? It said equal to a fraction, right? Yeah, good, Mason. There are actual fractions in it, right? There's actual fractions in it. It said equal to a fraction. So with this, that's a little bit different. So now we still want to think our opposite operations. We want to get n all by itself. So think if this was just a normal problem, how would you get rid of that -2? Well, right now, does that say -2 plus? Does that say -2 minus? Or does that say -2 times? Right. Very good. Yes, we would divide it. Was that you, Lynn, or Asia? Lynn. Okay, so yes, that's correct, Lynn. So what you would do, this is -2 times n. So the opposite of multiplying is dividing. So technically what we're going to do here is divide both sides by 2. Except I'm not going to use my fraction bar here because when on the right hand side, isn't there already a fraction? If there's already a fraction, do I want to add another fraction bar? No. But I now have -5 over 6 divided by 2. Now one of those numbers is a fraction and the other isn't. So what could I do to that 2 to make this look a little easier? Annalise? Put a 1 under it. Yeah, I would throw a 1 underneath it. And now we divide fractions. What strategy do we follow when we divide fractions? 3 words. Keep, change, flip. So we're going to keep the -5/6. We're going to change the division into multiplication. Good. And we're going to flip the 2 over 1 and make it a 1 over 2. Very good. Is there anything that needs to be reduced before I keep going? No. No. So just multiply across. What's negative 5 times 1? Negative 5. What's 6 times 2? 12. Negative 5 over 12. Good. Good. So now take a look at number 4. Does that look really similar? So we're going to follow that exact same strategy here. Let's try it one more time. So we have 5x equals 10 over 11. That means 5 times x, right? So I'm going to start randomly picking on some people at home. So Nick, what's the opposite of multiplication? Division. So we're going to divide both sides by 5, right? But now we have a fraction and one that's a whole number. So Jake Newcomb, what could I do with that 5 to make this look a little bit better? You there, Jake? All right, we'll move on to Olivia. Olivia, what could I do with this 5 to make this problem a little bit better? Very good. Add a 1 under it to make it a fraction. Now we got to follow our strategy, right? It's division, so we do our 3 words: keep, change, flip. Keep the first fraction as 10 over 11. Change the division into multiplication. Flip the 5 over 1 and make it a 1 over 5. Excellent. Now, it's up to you. If you like cross-reducing, you may cross-reduce at this point. If you don't, you need to make sure you reduce at the end, okay? So you guys weren't in person last time we cross-reduced. Do you guys know how to cross-reduce? Okay, and if you don't, just reduce at the end. Okay, so Asia, do you see anything that you can cross-reduce here? The 10 and the 5, because if you look diagonally, right, 10 and 5 can be reduced. What goes into both 10 and 5? Not 2, 5. You're thinking 10 divided by 5 is 2. That's what you were thinking. So, but they both are divisible by 5. So if I divide 10 by 5, it becomes 2, which is what you were thinking of. And 5 divided by 5 is 1. And then you can multiply across. 2 times 1 is 2. 11 times 1 is 11. But you don't have to do it like that. So if you're like, whoa, what did she just do? You could have just also, so like Annalise, if you're like, I don't know about that, right? You could have had 10 over 55, right? Just by multiplying across. And then if you look at 10 and 55, you'd have to be like, oh, 5 goes into both of them. So then you'd reduce from there. Either way, do what makes more sense to you. Okay? Questions about those ones? All right, onward. Number 5, we got 2/3 x times 8. Now, 2/3 with an x next to it. Do you see an addition sign? Do you see a subtraction sign? Do you see a multiplication sign? Do you see a division sign? No. So when you don't physically see a sign, what's happening? Addition, subtraction, multiplication, or division? Multiplication. Good. Yes. If you don't see something, technically we're multiplying. And what's the opposite of multiplying? Dividing. So we need to divide both sides by 2/3. Now this is another situation where a lot of the times when we're dividing just with nice whole numbers, we put our fraction bar, right? But aren't there already fractions? You don't want to put fractions in fractions, so use your division symbol. Okay? So I'm dividing both sides by 2/3. Okay? My 2/3 on the left will cancel. Oops. My 2/3 on the left, there we go, will cancel. And then on the right, I now have 8 divided by 2/3. So who can I pick on? Bailey, what should I do with that 8 to make this a little bit better to look at now that we need to divide? Put a 1 under it. Yep. Put a 1 under your 8. And we're going to now, what 3 words are we going to do? Keep, change, flip. Keep your 8 over 1. Change your division into multiplication and flip the 2/3 into a 3 over 2. At this point, if you would like to cross reduce, you can. If you don't like to cross reduce, then just multiply across and then reduce at the end, okay? Let's see. Lynn, do you see anything that you can cross reduce here? 8 and 2, what goes into both 8 and 2, Lynn? 2. So if I divide 8 by 2, it turns into a 4. If I divide 2 by 2, it turns into a 1. Right? And then just go ahead and now multiply. 4 times 3 is 12. 1 times 1 is 1. Now I have 12 over 1. That looks kind of weird, right? Can I leave it like that, though? Technically, but Jake, what else could I do? Just make it a 12, right? I will accept 12 over 1 as an answer. Technically, it's just a reduced fraction. But I personally think it looks a little weird, and I would just make it a 12. Okay, good. All right, let's try it again. Are these a little weirder than what we did last time? A little trickier? Owen, what do you think? A little trickier? Okay, a little bit. Okay. What about people at home? Are we doing okay? Is it a little trickier? Okay. Okay. Yeah. Okay. And some people are better at fractions than others. So that's why we just got to make sure we're practicing it. You know, and if you feel confident with it, work ahead and you can then check when we go over it. So then number 6, we have 3/5 m equals -9. So remember, this means 3/5 times m. Opposite of multiplying is dividing. So we're going to divide both sides by 3/5. Good. Now, Jesse, what should I do with that 9 to make this a little easier to finish up? Yeah, put a 1 under it. Make it both fractions, right? And now we're going to keep, change, flip. So keep your first fraction as -9 over 1. Change your division into multiplication. And flip the 3/5, make it 5 over 3. If you want to cross reduce, do it. If you don't, wait till the end. Dallas, do you see anything we can cross reduce? No? Anyone see anything we can cross? And you don't have. Yeah, no, that's okay. Well, and if you don't notice it right away, can you always just do it at the end? Yeah, it doesn't matter. You know, do what you're comfortable with. I'm not super picky. As long as it gets simplified, I don't care when it gets simplified. So yeah, you can divide though with the 3s. So 3 divided by 3 is 1. 9 divided by 3 is 3. And now we can just multiply across. So we'll have m equals, and with this one, guys, don't forget about your negative. What's a negative times a positive? A negative times a positive is a negative. So make sure you have your negative sign, okay? 3 times 5 is 15. 1 times 1 is just 1. Can I leave it like that? Yes. But how could I rewrite it to make it look a little nicer? Yep, just make it into m equals -15. Good. 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 Yeah, good job, Mason. All right. 2 more of these. Can you get out of here? Don't forget we're on an advisory schedule, so did it. Well, no, well, we're on an advisory schedule today, so today's bell schedule is a little different. So we get out of this class at 9:23 today. So just something for you guys to keep in mind with your next classes. Because I don't know if that changes anything. That might change some things for you guys. I sent out it. You don't have to. You only have to do advisory when you're in person. So if you're an eighth, so if you're an A through K kid, you'll do it when you're in advisory for A through K. When you're remote, if you're like a full remote person, then you'll also do it with the A through K kids. And then no, you'll I guess you technically have a little 30-minute break. Yeah. Yeah, because so this class will end at 9:23 today, and then from 9:30 till 10 o'clock is advisory. Yeah, Bailey, I'll send out, well, if you go to my announcements, I sent out the schedule this morning in the announcement. Okay, yeah, so if you look at it there, I attached it, and did we see that I sent out? Okay. If not, my announcement should also go to your email, I think, too. And they just populate in Canvas. I don't think I can put an attachment in here, though. Oh my gosh, someone's calling me. Okay. 1 second. I don't know who's calling me. Okay, I'm back, guys. Another teacher is having technical difficulties, and I guess I'm the person who gets asked all these questions. Yeah. I'm just very special and important. Now you know. All right, number 7. We got -2/5 p equals -1/4. So this one's, we got 2 fractions now, right? So we have -2/5 times p, right? So the opposite of multiplying is dividing. So we're going to divide both sides by -2/5. Mr. McCoy is screaming. Okay, so p equals, so now with this one, if they're both already fractions, do I got to worry about putting anybody over 1 or any of that stuff? No, it's already done for me. They're both fractions. So go ahead and keep, change, flip. We're going to keep our -1/4. We're going to change our division into multiplication, and we're going to flip our -2/5 and make it -5/2. Now, the negative sometimes throws people off. Does it really matter where you put the negative? Does it matter if it's on the top or the bottom or just in the front somewhere? No, it just needs to be there. Okay. Now, I don't see anything we can simplify, so let's just go ahead and multiply. First of all, let's see. Hannah, what's a negative times a negative? Hannah. All right, I don't know where Hannah is. Kaysen. Oh, yeah, that's okay, Hannah. What's a negative times a negative? You can respond in the chat if you want. A positive, good, yes. A negative times a negative is a positive. And then we're going to multiply. So 1 times 5 is 5. 4 times 2 is 8. And it's going to be positive. Good. Good, good, good. We okay? All right. Number 8, last fraction one. We got 2/3, I'm sorry, 3 over 2x equals 8 over 5. So 3 over 2 times x. Opposite of multiplying is division. So what are we going to multiply, or what are we going to divide both sides by? 3 over 2. Divide both sides by 3 over 2. Good. So x equals now, keep, change, flip. Keep the 8/5. Change the division into multiplication, flip the second fraction, make it 2/3. Sure, so tell me what to multiply on. Yep, good. 8 over 2, 8 times 2 is going to give you 16. 5 over 3 is going to give you 15. And is it okay to leave it like that as an improper fraction? No, this is totally fine. I would leave it like this. You do not have to change it into 1 and 1/15 if you don't want to. You can, but why do that extra step if you don't have to, right? We're almost out of time here. I want to look at one more problem and then we'll call it a day. Okay, sound good? Okay, so I just want to do one more practice word problem because it's on your quiz and I want to make sure we're prepared. So word problems, remember we're going to do what's called annotating our word problem. That's when we circle our numbers, we box our math action words, and we underline our question. So don't forget, when we do word problems, you always need to define your variable. On the quiz, I went ahead and defined the variable for you, okay, just because you have to type things in. But in general, define your variable. Then you need to write an equation. Oh, we're having a connection. Write an equation. And then solve and write your answer in context. So let's try out one of these. This is actually really similar to one that's on your test. So that's why I want to look at it. The balance of an investment account is $300 more than the balance 4 years ago. The current balance of the account is $550. What was the balance 4 years ago? Now I know a lot of you can just take a look at this and subtract and be like, oh, I know what it was. That's not the purpose. The purpose is that you know how to write an equation that represents this situation, okay? So first, let's go through and annotate. Where do we see some important numbers that are going to help us solve the problem? $300 is important. What else? Is there a number that's not important? It's there, but it doesn't really help us. 4 years ago, does it matter that it was 4 years ago? No. So I would X that out. Don't let that confuse you. What's another important number? 550, that's our current balance, right? Okay. Where do we have some math action words? More than means what? Very good, Jake. We add, yeah, addition. I see one more math action word. It's in the second sentence. It means equals. Is, good job. Yeah, is 550. Oh, I did a thing, guys. Oops, there we go. Okay. Yep, is 550 means it's going to equal. Why do I keep doing that? Sorry, you guys can't tell at home, but people here are seeing that I'm like minimizing my screen. There, okay. So it is 550. That means it's going to equal 550. So let's define our variable. Well, in order to define our variable, we got to know what we're being asked, right? What question is being posed to us? What are we being asked? What was the balance? We need to know the balance. What would maybe be a good letter to pick for balance? B. You could put B for balance. You could put M for money, right? pick X, maybe you always like X. I'm gonna do B for balance. So B equals balance. And I'm gonna put in dollars, just because, I don't know, maybe we're in England and we're working in pounds or something. Okay, so now we're gonna write an equation. A lot of the times what I like to do is I like to start at the end of my equation. Do we know what our equation has to equal? 550, right? Isn't that our current balance? We know it is 550, so I sometimes like to start at the end and put equals 550. Sometimes that's the most clear part of your problem is what it needs to equal. The other part's sometimes more complicated. Now, our balance is $300 more than it was before. And Jake told us more means addition. So how do you think we could maybe write the right side of our equation? What needs to be added, Jake? Yeah, 300 plus and then your variable, or your variable plus 300, either way. Yeah, so you could do 300 plus your variable, which in this case we did B, or B plus 300, either order. Good. On your test, that's something I expect to see. You'll have to type it in to the best of your abilities, okay? Now we need to solve. What would we do to solve this? We want to subtract 300 because isn't the 300 positive, Annalise? Yeah, okay. Good job. So subtract your 300 from both sides. And you're going to get B equals 250. 250 what? Dollars, right? And then how could we maybe write this answer in context? Like as a statement. Jake? Yeah, sure. The balance 4 years ago was $250. Perfect. The balance 4 years ago was $250. Very good. Very good. We're not going to do number 2 for today just because we're running short on time with advisory.